Hello everyone, I'm Smriti Sinha here, and the topic that we are going to study today is methods of purification of organic compounds. So this is the part of organic chemistry itself. We are going to see how to purify few of the organic compounds after synthesis or after their extraction from the natural sources. So first we are going to see the theory part, and then we are going to move towards the MCQ, that is the practice session. Let's start with the theory part. So what is exactly purification? So purification means removal of unwanted impurities or removal of unwanted compound, element or substances from the desired organic compound. Purification methods are generally categorized in these types for organic chemistry. So the first is sublimation, second is crystallization, third is distillation, fourth solvent extraction, and fifth chromatographic techniques. So let's see each technique in detail. So we are going to see first sublimation technique. Sublimation is a technique which is generally used to purify solid compounds. The compounds which are sublimatory, that is, the solid compounds which gets converted into gas without passing through liquid state. So few of the solid compounds like naphthalene, anthracene, benzoic acid, camphor, these compounds directly pass to gas state without going through the liquid state. So in general, what is expected is that if you heat solid, it gets converted to liquid. Liquid heated further gets converted to gas. But in our case now, solid is directly converted to gas without passing through liquid. And such solid compounds can be purified by sublimation technique. Here, typically what happens is that you have to take a china dish. Hi Ankit, hi Rushikesh, hi Abdul. So you have to here take a china dish. In this china dish, you take any sublimatory solid that you need to purify, like ammonium chloride. Then heat it. As you heat it, and on top of that, you have to keep an inverted funnel, and you have to block this funnel with a cotton plug so that whenever your solid gets converted to gas, does not goes out, it remains inside. Hi Nikita. So now what you have to do is, once you start heating it, now your solid over here gets converted to the gas, and its vapor is collected over here at the top of the funnel where it gets condensed, and then after some time it cools down and crystallized. So you will get the purified solid on the top of the funnel. In this way, you see here, like ammonium chloride has solidified here at the cold part of this funnel. Hi Rushikesh. So this way you can do your solid purification of the impure solid. Okay, but the condition is that your solid should be in sublimatory condition. Next is crystallization. What is crystallization technique? Now crystallization technique is a technique where you need to again purify the solid compound. So the crude solid, that is the impure solid, here you need that this impure solid should be in more amount, the main constituent, and the impurities can be present, some impurities. It is not that a single impurity, any different impurity can be present with this crude solid. Now, if your crude solid is one single substance and it have few impurities in it, so you can purify it by doing crystallization process. Now, the principle over here is that your main solid and the impurities have different solubility in different solvents. Okay, so the main principle is that the compound and its impurity have different solubility in a given solvent or in a different solvent. So suppose if you see crude benzoic acid, it will be somewhat yellowish color. Okay, now if you take this crude benzoic acid and try to dissolve it in normal cold water, it won't dissolve sufficiently. In very less amount, it will dissolve in cold water. But as soon as you start heating this solid, it will be get converting into the complete solution. That means in cold water, it was only 20% soluble, rest was as a crude solid itself. But when you heated this solution, the whole solid got dissolved in your solution and you got a clear solution. At this higher temperature, you get a clear solution. That means that for the crystallization technique, you need to choose such a solvent which dissolves the solid very little amount or sparingly at the room temperature, and it dissolves it completely at the higher temperature. So while choosing the solvent for crystallization, you need to remember that the solvent should dissolve your solid completely at high temperature and sparingly or little bit at the room temperature. Now this solution along with the large amount of your crude solid is now saturated solution. It is heated, then it is cooled down, and then you can see the crystals over there, which is removed via filtration. So in short, okay, Akash, do you want me to repeat this point? So I will tell you the technique. So I hope you will understand by seeing the diagram. Okay. So in this crystallization technique, generally there are 4 steps. The first one is preparation of saturated solution. Second is hot filtration. Third is cooling of filtrate, and fourth is filtration. So by this diagram, I hope all of you will understand what you have to do is you have to take the crude solid and you have to choose a particular solution. Okay, solvent over here. For this crude solid, take a particular solvent. You cannot choose any solvent. You have to choose such a solvent in which this solid is only soluble at high temperature, means completely soluble only at high temperature and sparingly soluble at low temperature. You need to choose such only solvent. You cannot choose any other solvent like this. So for benzoic acid, water is a good solvent because benzoic acid is very less soluble in water at room temperature and highly soluble in water at high temperature. So benzoic acid, water is a good solvent. Now once you start heating this, the impure solid does not get, actually the impure solid get dissolved in the solvent, and even your this crude solid also, the main solid also, and you get a saturated solution over here. Now how to saturate this solution? You have to keep the solution heating and make the amount of solvent less. Whatever amount you have taken, suppose 10 ml, reduce it to around 7 to 6 ml, then you will get a concentration solution. Now to this concentrated solution, you need to keep it to cool, okay, at room temperature. You cannot do instant cooling. If you start doing instant cooling around the ice, what happens is that if your crystals will be not formed very properly, you have to let it cool at room temperature slowly, and as time passes you will be able to see a clear crystals in this solution. So here you can see some crystals are formed here, white layer in this solution. Now just filter it by using filter paper or vacuum filtration and you will get your pure solid. So this is the way how you can use the crystallization technique to purify your solids. Next is choice of solvent. So many times assertion questions or multiple choice question comes on this part. So while choosing the solvent for crystallization, you need to remember few things. First, the compound should be crystallized. The compound which you need to crystallize should be sparingly or least soluble in solvent at room temperature, but highly soluble in solvent at high temperature. Second, your solvent and your solute should not chemically react with each other. If your solvent and your compound that you are going to purify, if they are reacting with each other, you will get a third product. Okay, that's why you should remember your solvent should not react with the solid you are going to purify. Next, your solvent should be volatile. That means it should be easily removed from the solution. Otherwise, what happens? you get the solvent impurities added to your solid too. So your solvent should be volatile in nature. So these are the three important points while choosing the solvent for crystallization. Next is distillation. Distillation technique is generally used for liquid. Here, the principle behind distillation is that you need to separate the mixture of liquids which have difference in their boiling point. So if you have a mixture of liquid and those mixture of liquid have difference in their boiling point and you want to separate it, you can use distillation technique. So distillation is an important method to separate first volatile liquids from non-volatile one like acetone from water. Second, liquids having sufficient difference in their boiling point. If two liquids have more than 50°C difference in temperature in their boiling point, then only you are able to separate these two liquids. Or else you need a volatile and a non-volatile, two types of impurities and liquid together, then you can use this technique. So the important thing to remember here is for distillation technique, you need to remember the difference between your liquid and the impurity should be greater than 50°C. That is sufficient difference should be there. So now what you need to do for this distillation technique? So here in this conical flask, you need to take your two liquids, means your pure liquid and the impurity, whatever is there, which you need to purify. So you are going to take here mixture of liquid, actually the pure liquid which you want and the impurity along with that. You are going to heat it. As soon as you start heating it, the boiling point difference will be there. Correct? The liquid which has low boiling, the liquid which has low boiling point will boil first and then it will go as a vapor above and then pass through the condenser where water is allowed to pass through condenser. So due to this water, your cooling effect will be there and your vapor here will be condensed to liquid and you can then collect this liquid over here. Okay, so this is the first liquid which you have collected. If you want to collect the second liquid also, you can remove this vessel at a particular temperature. As you know, if your first liquid was boiling at 50°C, around at 52, you can stop collecting this liquid because you have got your complete liquid in a pure form. You remove that flask and add the second flask over here to collect the second liquid. So in this way, you can even separate the two liquids or you can even purify the one. So here liquids actually boil without decomposition at atmospheric pressure. Those liquids can only be purified by this technique. So for this technique, you need to remember one thing. You need such a liquid which does not decompose at atmospheric pressure. If your liquid starts decomposing at the atmospheric pressure, that means that you cannot use this technique because your liquid will be totally destroyed. Next is fractional distillation. So when do we use fractional distillation and what is its difference between this fractional distillation and simple distillation? So for fractional distillation, if you have a mixture of two liquids in which there is no much difference of their boiling point, means their boiling point is only differing by 10 or 20°C, means not much difference is there between these two liquids in their boiling point. In that case, you need to use this technique, that is fractional distillation. In this method, the apparatus is same as that of the simple distillation, only one more fractionating column is added over here. This fractionating column help us to purify or separate these two liquids which boils almost at the same temperature. So here again you will take the liquid along with its impurity where the both liquid boiling point temperature is having not much difference. If you start heating it, both will start boiling, both will start going above. But the thing is, the one which boils at higher temperature will rise up first and then it will go in the condenser first and will be collected first and then the other. Next is distillation under reduced pressure. So next method is distillation when you do under reduced pressure. Why we need to do distillation under reduced pressure? Why not we we can do simple distillation or fractional distillation. The reason behind here is some liquids have very high boiling point, and the problem is even though they have high boiling point, when they reach this boiling point they start to decompose, and then you cannot get this liquid in pure form after distillation. So for such kind of liquid which have high boiling point and start decomposing at their boiling point, you need to do distillation at reduced pressure. In this method, the liquid is made to boil at a temperature which is lower than its normal boiling point. This is done by reducing the pressure on the surface of the liquid. Once the liquid starts boiling at the lower temperature, then this liquid gets collected without decomposition in your collecting flux. Now here pressure is reduced by using water pump or vacuum pump. So you need to remember your pressure of this complete apparatus. How to reduce this pressure? By using the vacuum pump or water pump. In soap industry, glycerol is separated from soap by using this technique. So we have seen many advertisements, correct? Low glycerol soap. So how to separate this glycerol from soap? By using this distillation under reduced pressure. Next is solvent extraction. In this technique, the organic substance which is present in aqueous solution can be extracted and purified by shaking it with organic solvent in which the substance is more soluble. So before extraction, if you see, you have an organic compound which is present along with water. So this is organic compound plus water solution. Now this organic compound is soluble in water and cannot be easily removed from water. So now what you will do, you will choose a solvent layer, another solvent layer, which is a suitable solvent layer, and it is a organic layer now. Okay, means organic solvent, not water. So you have to choose a organic solvent over here. Once you choose the organic solvent, you need to see that this organic solvent is not miscible in water. Okay, means water and the organic solvent should form two different layers. Okay, such type of solvent only you have to choose. The second thing, this solvent should be capable of dissolving this organic compound in it from water. Means it is able to remove the organic compound and dissolve it in itself. Another thing, this organic solvent should be volatile. Then only once the substance is dissolved in this organic solvent, the organic solvent can be evaporated and you can get your pure substance back. So what you are going to do is, suppose I have a mixture of some compound in water. I will take that first. This is an extraction funnel. Now in this, what I will add is, suppose ether. You can add chloroform, ether or acetone, whichever organic solvent you choose. You remember it is volatile, it is not miscible in water, and it can dissolve this organic compound. Once you add this two layer, close the knob, shake this very well. After shaking, you will see two again layer with different color. Now the water is pure water over here. Whatever compound was dissolved here has went above in the organic solvent, because the organic solvent was able to dissolve this compound more than that of water. So it took the organic compound along with itself. Now open the knob, collect this layer first below, discard it because you don't need it, and then collect the above layer. This above layer will be useful for you because it is having your organic compound. Now this liquid, whatever you have choose, is actually volatile. So evaporate it on evaporating dish and you will get your organic compound in a pure form. So this technique basically you need to use for such solid which is now dissolved in water. You want to remove it from water, and this technique is used by which method? By dissolving that organic compound in a suitable organic solvent, okay, which is in which the organic compound is more soluble than water. The next method is chromatographic techniques. So many of you must have heard about this technique, right? So chromatographic technique is actually a technique which is used to separate components from a mixture and also purify them. It is even used to see or identify the compound which is formed in reaction is pure or not. In chromatography technique, there are two phases. One is the stationary phase, the other is mobile phase. So as the name says, stationary phase is non-movable phase, mobile phase keeps on moving. This technique is based on the principle that there is difference in rate at which components of a mixture move through the stationary phase along or in the influence of mobile phase. So how much that component is dissolvable in mobile phase and how much it can be adsorbed on stationary phase, that will decide the movement of the two different solutes or two different liquids on that stationary phase. Now, first the mixture of the component is loaded at one end of the stationary phase and then it is dipped in the mobile phase where the pure solvent is allowed to move along the stationary phase. Now, this pure solvent takes your component along with itself. So, now what happens is that you have to take a, like I will discuss this technique also. This is thin layer chromatography beaker. Then take a stationary phase, put the component which you need to purify, then put a solvent, suitable solvent over here. Now this component should be above the solvent layer. Place a lid and start running this solvent. Now this solvent will be adsorbed on this stationary phase and along with this your component will start moving. The two components will move with a different rate with how much it is soluble in mobile phase. If it is more soluble in mobile phase, it will move fast, and if it is less, it will move slow. Okay, and then it can get absorbed on this and you will get the two components separated from this mixture. So this is how this chromatography techniques work. So in this chromatographic technique, the main thing is relative affinity of component towards this stationary phase. How much it can get adsorbed on the stationary phase, on that rate the component will move on that stationary phase under the influence of mobile phase. The stationary phase can be a solid or liquid. The mobile phase is liquid or gas. But there are two types of chromatography depending on your stationary phase. The first is adsorption chromatography and second is partition chromatography. So let's see first adsorption chromatography. The adsorption chromatography works on differential adsorption principle. So this question comes for MCQ. Adsorption chromatography works on which principle? It works on differential adsorption principle. That means different solutes get adsorbed at different extent on stationary phase. So whatever solute you choose, that solute will get absorbed at different rate on the stationary phase. Adsorption chromatography is again of two types. First is column chromatography, second is thin layer chromatography. Now we'll see column chromatography. In column chromatography, you need to take a burette type, that is a apparatus. You can even take a burette. You have to fill it with silica or aluminium. Okay, this helps as a solid phase or stationary phase. On this, you have to load a substance, that is the mixture of component which you need to separate. This is a mixture of A, B, and C. Now you are going to allow the suitable solvent run through this. Now this is actually, now the solvent will try to come down under the influence of gravity. As the solvent will move down, it will take all the components along with it. How much the component is soluble in this solvent and how much it will be able to adsorb on this stationary phase. On that way, the A, B, and C will get separated out. And this way, you can get the three compounds in a pure form. And once you get this three separated out, you know that C will come first out of this burette. Collect C, remove that beaker, then put second beaker, collect B, then put third beaker and collect A. And this way you will get the three components in a pure form. Next is thin layer chromatography. In thin layer chromatography, that is TLC, you need to take a thin plate. On that, put silica or aluminium as stationary phase. Put the mixture which you want to purify here. The spot should be above the mobile phase. put mobile phase in the beaker at below. Then you have to put a lid over here. The mobile phase will start running. As it will run above, it will carry the mixture along with it. And when at the end, if you see this plate, there was 3 compound in it. You will get the 3 compounds separated on basis of 2 things. First, how much this compound was soluble in the mobile phase, and second, how much it can get adsorbed on this chromatographic plate. Next is partition chromatography. In partition chromatography, the stationary and mobile phase both are liquids. Here, the separation of component takes place by continuous differential partitioning of component between stationary and mobile phases. So, in partition chromatography, example is paper chromatography. So, paper chromatography is very similar to that of TLC. Just the thing is, instead of a plate or a glass, you need to take a paper. So, you take a piece of paper, not any paper. There is a particular paper for paper chromatography. That paper you need to choose, take the mixture on it, whatever you want to separate, put it in a suitable solvent, allow it to run. How much it is soluble in that solvent and how much it is adsorbed on this paper. Now, this paper is actually dipped in water, means this paper has a stationary phase water on it, and the mobile phase is a suitable organic solvent which is running above it, and these 2 solvents, that is water and this organic solvent, will decide how much this will get adsorbed on paper, and the 2 components can be separated out from this mixture. Now, last part is the retention factor. So, chromatography techniques or this column chromatography and TLC, everything if you see has 2 things in them. One is the baseline where you put the spot. The other is how much your solvent has run. The second thing is where your solute has run. Because once you put the baseline, that baseline if you put and if you start running the mobile phase, the mobile phase will carry the solute. It will leave the solute somewhere till where it can run, and it will go alone till the top. So one will be the solvent front, one will be the spot front, one will be the baseline. The distance between the baseline and the solute front is the distance called x, and the distance between the baseline and solvent front is called as y. Now, RF factor means distance traveled by solute from baseline divided by distance traveled by solvent from baseline. That is x divided by y. This is called as RF factor or retention factor. Now we are, this session is in English, Sunil. Now we are going to move towards the MCQ part. Now I want answer from you too. Now first is sublimation, dissolving and filtration can only be carried out in. So which type of mixture can undergo sublimation purification also, by dissolving also, and by filtration also? So out of this, what you think, which one can be the correct answer over here? So your correct answer is solid mixture, because solid mixture can only undergo sublimation, because sublimation means any solid which directly undergo changes to gas without going to liquid. So only solid can be purified by sublimation, and it can even purified by dissolving, and it can be even purified by filtration. Therefore the answer is option D. Next, crystallization is used to purify. So how can you means which of this following you can purify by crystallization technique? So out of all this, you can purify only sugar and fertilizers by crystallization technique. Only sugar cannot be purified, you know that, because only sugar you don't need to purify, correct? It is pure. Fertilizer pure. Then salt from a solution you can use, but this cannot be purified by crystallization actually completely. So the main answer is sugar and fertilizer mixture. Next, the anhydrous agent used to remove water from ethanol distillate may be. So which reagent is used to remove water from ethanol? So actually, if you purify ethanol by distillation technique, you get few amount of water in it also. And if you want to remove this water from this ethanol, you need to use some anhydrous reagent. Anhydrous reagent means a reagent which removes water. So which is that reagent which will help you out to remove water from ethanol without reacting with ethanol? So the correct answer over here is option C, that is calcium chloride. So calcium chloride is one of the anhydrous reagent which adsorbs water on its surface, leaving the ethanol in a pure state. Next, only one type of atom is found in. So in which type of substance or compound only one type of atom is found? So this is a very simple question. That will be the pure substance. So only pure substance have all the atoms of the same type. Next, which of the following is a technique of purification of organic compound? So out of this, which one is the technique for purification? Just now we have seen that is distillation. In distillation, it can be simple distillation, it can be fractional distillation, or it can be distillation under reduced pressure. Next, how will you separate a solution of benzene and chloroform? So if I give you a mixture of benzene plus chloroform, how will you separate it out? So which technique will you use to separate this mixture? So your correct answer is actually distillation, because for sublimation you need solid. For filtration also you need some kind of solid, correct? For crystallization also you need solid. Only distillation is there where benzene and chloroform, both are liquids, can be purified or separated from each other. Next, chromatography is used for purification of. So by chromatography technique, you can purify which type of substance, solid, liquid, or gas. So actually by using chromatography technique, you can purify all of these three substances. Next, an organic compound from its aqueous solution can be separated by. So how can you separate an organic compound from its aqueous solution? So if you want to separate the organic compound from aqueous solution, you can use solvent extraction technique, in which you will take an extracting funnel. In this extracting funnel, you are going to add the aqueous solution along with your organic compound. Okay, then on top of that, you will put suitable organic solvent. You will shake it. After shaking it, the organic compound from aqueous solution will go in organic solvent. You will remove this water by using this knob, discard this water, then collect this, in which your organic solvent and organic compound both are present. Just evaporate it and you will get your pure compound. That is solvent extraction technique. Next, two volatile liquids A and B differing in their boiling point by 15 Kelvin. Which process can be used for separation? Now you have two liquids A plus B with you, which is in the form of mixture. You want to separate it. Okay. Now you know you can separate it by distillation. This everyone knows that two liquids can be separated only by distillation. But which type of distillation? So the difference in boiling point between these two liquid is only 15 Kelvin. So very less difference in the boiling point. And in such case, where the two liquids have very less difference in boiling point, they can be purified or separated only by fractional distillation technique. Next, name the method used to separate a mixture of iodine and sodium chloride. So how come you can separate a mixture of iodine and sodium chloride? So iodine and sodium chloride both are actually solids. Both out of these two, you can separate them. Iodine is a sublimentary substance. So you can separate them by sublimation. So if you take these two components together in a petri dish and you put an inverted funnel, along with it a cotton over here, and if you start heating it, once you heat it, the iodine will evaporate, go above, it will be sublimated, so it will not convert into liquid, just solid, and then solid will get directly converted to gas, and the cold surface of the funnel, it will get condensed. You can remove this iodine, and NaCl will be there below itself because it is not sublimated compound, and you can collect NaCl from here and the iodine from above, and therefore sublimation can be used to separate these two. Next, the fragrance of flower is due to presence of steam volatile organic compound called essential oils. So any flower has a particular smell like rose, lilies. This is due to the presence of essential oils. Now, these essential oils are generally insoluble in water at room temperature, but they are miscible with water vapor. Means these essential oils, if you try to dissolve them in water at your room temperature or 25 degrees Celsius, they won't dissolve in it. But if you try to dissolve this essential oil in water vapor, that is hot water, it will dissolve. So what is the suitable method for extraction of this oils from flower? So which method will you use to extract this oil from flower? So the extraction method will be steam distillation. So you will take the flower, okay, you will make it the paste, proper paste of that flower, and then you will take it in a conical flask. To this you will add water, okay, and then you will take this type of solution, you will heat it. Once you starting heating it, the essential oil along with water vapor will go above, then it will go in the condenser, it will cool in the condenser, and then you can collect it below here. Okay, once you collect this, the water will come at room temperature, the oil will remain on the surface of the water, which you can easily remove it out. So this way you can extract essential oils from any flower by using steam distillation technique. Next, name a suitable technique of separation of mixture of calcium sulfate and camphor. So if you want to separate calcium sulfate and camphor, which technique you will use? You know that camphor is sublimated compound. If you keep open the camphor bottle after 2 to 3 days, you won't be able to see a single piece of camphor in that because it is sublimated. It will sublimate in the environment in the gas. So you have to remember that for this technique where you have sublimated compound and a non-sublimated compound and you want to separate them, use sublimation technique. This is the trick. Next, suggest a method to separate a mixture containing acetone and ethanol. So how come you will remove this acetone and ethanol from each other or separate them from each other? Both are liquids and both liquids can be only separated by distillation technique. Next, suggest a method to purify naphthalene. Naphthalene is again a sublimated compound and hence to purify it you need sublimation technique. Next, suggest a method to separate a mixture of ortho and para nitroaniline. So if you want to separate ortho and para nitroaniline from each other, which technique you will use? So remember, both are actually solids. One is yellow, one is dark orange color solid. So these two solids, you cannot separate it by crystallization technique. You cannot separate it by extraction, not even by distillation. So the only technique left is chromatography. In chromatography technique, both this para-nitroaniline and the ortho-nitroaniline will have different adsorption capacity on the adsorbent, that is on the stationary phase, and by doing so, means by running these two on the stationary phase, they will adsorb at different position, due to which you can separate them out easily. Next, in chromatography, mean hydrogen solution is used to detect. Now, why do you need solution in chromatography technique? As I have told you, in chromatography technique, Once the solvent runs and you get 2 spots or 3 spots depending how many compounds you had in your mixture on this plate, but these spots cannot be visible by naked eyes. So this spot can only be visible in UV chamber. So if you put this in the UV chamber, you will be able to see the spots, or they are even visible in iodine. So iodine chamber is made. In this iodine chamber, if you keep this TLC plate, the spots can be visible. But there are few compounds which cannot show spot even in UV chamber or in the iodine chamber. So in that case, they need a particular solution, and mean hydrogen solution is generally used for amino acids. Because if you want to separate amino acid, you will get different spots of amino acid on this chromatographic plate or paper chromatography, but they won't be able, you won't be able to see these spots on UV chamber or iodine chamber. In that case, you have to spray some mean hydrogen solution over here. As soon as you spray the mean hydrogen solution, you will be able to see different color spots here. So amino acid is the one which needs mean hydrogen solution for detection. Next, in chromatography, RF means. So in chromatography, RF means which type of factor? Retardation factor. So remember, RF full form is retardation factor. Next, distillation under reduced pressure is used when? So when do you need distillation under reduced pressure? So for this type of distillation where you need reduced pressure, why? Because if you do it at normal pressure, your liquid will decompose. So liquid which has high boiling point and they decompose at their boiling point need distillation at below boiling point or under reduced pressure. So answer is option A. Next, what should be the property of solvent used in crystallization? So which property of solvent is used in crystallization? First, the impure compound should be sparingly soluble in it at room temperature, correct? So for crystallization, you know that the solid which you need to purify should dissolve very less in the solvent at room temperature, but it should dissolve completely in that solvent at higher temperature. That means both the statements are correct, and therefore answer C is correct, both of the above. Next, assertion type question. Assertion: essential oils are purified by steam distillation. Reason: essential oils are volatile and are insoluble in water. So here essential oils are purified by steam distillation. This is correct. Actually, we have seen, because they only dissolve in steam, so they can be only purified by steam distillation. And the reason that essential oils are volatile and are insoluble in water and they are only soluble in steam is the correct reason too. So assertion is also correct, reason is also correct, and reason is the correct explanation for assertion, and therefore option A is correct. Next, a substance which decomposes below its boiling point can be best purified by. So a substance which decomposes at its below or at its boiling point can be only purified by distillation under reduced pressure. Means the substance is not allowed to reach its boiling point, so it won't decompose. Next, match the ideal method of separation of component in a mixture in list 1 with list 2. So the first, sand from a mixture of sand and water. So if you want to separate a sand from sand and water mixture, you need to do filtration. Next, kerosene from a mixture of kerosene and water. For this, kerosene has low boiling point, water has high boiling point, so they can be easily separated by just distillation technique. Next, alcohol from mixture of methyl alcohol and water. So methyl alcohol and water can be separated by fractional distillation technique. Naphthalene from naphthalene and lead chloride. So naphthalene and naphthalene lead chloride can be separated by the sublimation, because naphthalene is a sublimentary solid. It can sublimate, leaving behind the lead chloride. Next, pure water from impure water. So pure water from impure water can be separated. So here you can say that pure water and impure water can mainly be separated by distillation. And for this kerosene and water, you can even use separating funnel. So there fractional distillation and separating funnel both can be used, and pure water and impure water can be only separated by distillation. Next, during a hearing of a court case, the judge suspected that some changes in the document has been carried out. He asked the forensic department to check the ink used at two different places. According to you, which technique can be give the best results? So the judge want to know that the two inks used at two different places are same or different. So for this, which technique you can use? So you can use the best technique is thin layer chromatography. In this, both the inks will be given spotting on a stationary phase. Mobile phase will allow to run. If the mobile phase run, the same mobile phase, the same stationary phase will be used. And if you get the spot, the next spot, once the mobile phase run, if you get the next spot at the same distance on the two plate, means you had the same ink. If you get the two spots at different place on the TLC plate, that means you had two different inks. That means if the RF factor is same to same inks and RF factor different to different inks. So thin layer chromatography can be used to know that. Next, the principle involved in paper chromatography is, so we have seen that partition principle is used in paper chromatography. Next, match the separation of component in list 1 with list 2. So first, naphthalene from naphthalene and sodium chloride. So I have already told you this is sublimation, because naphthalene can be sublimate and sodium chloride can remain below in the petri dish itself. So by sublimation, we can separate these two out. Next, cream from milk. If you want to separate cream from milk, you need to use centrifugation that we do at home. Okay, that. Then next, kerosene oil from kerosene oil and water. For this, you need to use separating funnel. Separating funnel can help you to remove kerosene from the water. Next, lead nitrate from aqueous solution of lead nitrate. So as you can see, you want to separate the lead nitrate from aqueous solution of lead nitrate, where both have different evaporating point. So that is distillation. And last is ammonia from aqueous solution of ammonia just by boiling, because ammonia is a gas. At a boiling point, it will leave the solution completely, leaving behind the aqueous, that is water, below. Next, assertion type question. Assertion: glycerol is purified by distillation under reduced pressure. Reason: organic compounds in liquid state are purified by distillation. Okay, so glycerol is correct. It is purified under reduced pressure. That only we have told in soap industry. If you want to remove glycerol from soap, you should use the steam distillation technique under reduced pressure. Okay, so the assertion is correct. Organic compounds are purified by distillation. This is also correct, but reason is not correct explanation for assertion. Correct. So here the assertion and reason both are true, but reason is not correct explanation for assertion. That's why option B is correct. Next, assertion: a mixture of acetone and methanol can be separated by fractional distillation. Okay, so this is correct. Actually, if you want to separate acetone and methanol, you have to use fractional distillation, because the difference between the two boiling point is very, very less. So both boiling point difference is less, and in that case only one distillation technique can work, that is fractional distillation. Reason: the difference between their boiling point is very less, so reason is also correct. Assertion is also correct, and reason is the correct explanation for assertion. Therefore option A is correct. Next, assertion: A mixture of benzoic acid and naphthalene can be separated by crystallization from water. Yes, you can do that. Benzoic acid and naphthalene you can separate by crystallization of water. Why? Because benzoic acid is soluble in water in hot condition, but naphthalene is not soluble in water in hot condition. So if you take these two mixture in water and you will heat, only benzoic acid will get completely soluble in water and you can remove it and the naphthalene will remain as it is. The reason, benzoic acid is soluble in hot water, but naphthalene is insoluble in hot water. The reason is also correct. Therefore, assertion and reason both are correct, and reason is the correct explanation for assertion. That's why here option A is correct. Next, assertion. A mixture of sugar and benzoic acid can be separated by shaking with ether. Sugar is insoluble in water. Obviously, reason is wrong. You all know that sugar is soluble in water, correct? So reason is wrong, but assertion is correct. Why? Because benzoic acid can dissolve in ether and it can go out in ether easily, leaving behind the sugar. So if you take mixture of sugar and benzoic acid together, shaken in ether, the ether will take all benzoic acid along with itself, leaving the sugar behind. Filter it, you will get the sugar, and evaporate the ether, you will get the benzoic acid. So this way you can separate, means assertion is correct, but your reason is false, that is option C is correct. Next, assertion. In sublimation, a substance changes directly from solid to vapor without passing to liquid state and vice versa. This is true because in sublimation, solid gets directly converted to vapor or vapor gets directly converted to solid without going to liquid. Reason, distillation involves two processes, vaporization and condensation. This is false because we are talking about sublimation, not distillation. So actually distillation is correct. Your reason is correct, but this reason cannot be the correct explanation for assertion because these two are two different techniques, correct? So both are true, but they are not the correct explanation of each other. So your option B is correct. And that's all for today. Thank you. If you like the video, please press the like button, share this video to more and more of your friends, and please subscribe this channel and stay tuned. Thank you.